Everyone, we started looking at GET201. I believe you can hear me clearly. I believe you can hear me clearly.
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir. We can hear you.
Okay. Yeah. Okay. So thank you
Yes, sir.
for that response. Now we started looking at applied electricity part 1, which is for the whole of engineering students, and physics. And I tried to introduce you to what is an electrical engineering and an electronics engineering profession. And I was able to show you quite a number of areas of usefulness and application of the electrical and electronics engineering. And from there, we introduced everyone to, if you don't mute yourself, I will remove you from the platform. You must mute yourself before you join. I think I said this last time. If you don't mute yourself, I will remove you. And if you don't write the correct, the full information about yourself, I will remove you. If I don't have your matric number and your full name, you'll be removed from the call. Full name and your matric number. Surname first. Some people do not who do not comply with this, so I will be removing them now. Maybe I should start from that first. Once you call me, you try as much as possible to mute yourself so that there won't be problem of interrupting the class, because this is being recorded and you can see a number of other students coming into the if you are joining, join with your microphone muted so that you don't disrupt the class. And if you are joining, put your matric number, name with surname first before we commence the lecture. If anyone has name without matric number, such a fellow will be removed from this call. If anybody has his microphone on, such a fellow will be removed from this call. I don't need to be repeating this every time. I have given the ground rule as at last lecture. So my class, remove your hand once you can hear. Don't raise any hand when lecture is ongoing. If I get to a level that you can ask questions, I will give you that privilege to ask questions. But if you don't enter with your full name, you will be removed immediately. And with your matric number, you'll be removed immediately. That's the rule of this place. Now, as I was saying before, I was interrupted by the people who are just coming in. I said that we were looking at electrical engineering area of application and how it is important to you. This was what we looked at during our last lecture. And from there, we were able to introduce you to different parameters of different elements of an electrical engineering. And such element, circuit element for an electrical engineering, we were able to make mention of the fact that there is resistance. You have resistor or resistance, the conductor that can be a combination of resistance, inductance, and at a number of times you have the capacitance as well. And then we said that there are two major energy sources in electrical engineering. We talked about the current and the voltage as the sources of providing energy. And then from there, I think we went straight away to looking at dependent and independent sources of energy sources in a particular system. And we came up with what we call the ideal source, and which is another name, ideal source, which other name is independent source, which is not depending on any source, and it can allow as much energy as it has to be used to feed the load. And we call it a fixed source. That is, it has a fixed amount of energy that it can give at any point in time. And then, which is another name for controlled source. The ideal source is another name for independent source. That is, it's not depending on any, but many other facilities are depending on it. So from there, after having looked at that, we will be board on your screen now, which is type of ideal source. And I told the ideal source, you have something of this nature, which I introduced to you during the last lecture. Now you have the voltage source and the current source, which is always constant or fixed in value. And then you have the independent source. And I told you that the independent source is normally represented by a diamond symbol. Whenever you see a diamond symbol in an electrical circuit, know that it is an independent source. But whenever you see bubble with positive and negative terminals as shown in this place, then you are talking of the independent source. And likewise, when it is positive and negative inside the bubble, you are talking of a voltage source. A voltage source. Or when you have a long plate and a shorter plate connected as it is shown here, it is also a voltage source, whereby the longer plate is referred to as the positive terminal, while the shorter plate, thicker one, is referred to as the negative terminal. And then if it is current will always flow as you have seen it, flowing out of the positive into the negative. So you can see the current flowing out of the positive terminal into the negative terminal. So these are some of the information that you need. We say it flowed downstream. So these are some of the information that you need concerning ideal or independent source. And then the dependent source, which is more of a diamond symbol with positive. When you have positive and negative inside that diamond symbol, it's telling you there is a voltage source. When you have arrow pointing from one end to the other, it shows you there is a current source. Even if IS or VS is not there, you should know it straight away that this is a voltage source. is a current source. And at that point, we have four types of sources in the dependent or control sources. We have the voltage control current voltage source. We have the current controlled voltage source, which we call CCVS. We have the voltage control current source, and we also have current control current source. And the relationship is as represented on your right-hand side, where Vs is equal to mu Vx. Vs can, for the current control voltage source, Vs is equal to RIs. So we are relating Vs to Is. So that shows you that you have a current controlled. That is, current is the one that is varying or that is dependent. Voltage source, the voltage source remains fixed. The value, the amount that you can get from that voltage source remains definite. Then, if you have voltage control current source, it means current is the one that is definite in value, while Vx is the one that is dependent on the current source. Likewise, we have the current control current source, the same explanation goes. With these ones, we have done during the last lecture. And then I presented them to you in this form so that you can see the way we normally deal with them when it comes to electrical network. With this, I think I have done. We are now going to the lecture for today. Yes, somebody is raising up his hand. Can you write? You didn't write your matric number, so you are not eligible to ask question here. You have not followed the due process, so you cannot ask any question, please. Yes. So Daddy, can you go ahead with your question now? Please make it very fast. So Daddy, can you go on with your question? Be fast with it.
Sir, please, can you explain voltage controlled voltage source again, please?
These are the things that we did last week. I'm just referring back to them. I expected you to have been able to catch it last week, but I'm just reviewing what we did last week. I won't be able to be going back, but I will do this for the first time. Then the next person, you are not well ready for this lecture because you don't have your matric number. So on the account of that, he said that to explain voltage control, voltage source again. I think I get you right. So let me move a little back. This is what the relationship I have for them. I told you whenever you have the diamond symbol, it tells you straight away that you are dealing with dependent source, otherwise known as controlled source. And in that case, if you have double positive and negative symbols inside the diamond symbol, then you are dealing with voltage, because voltage has positive and negative terminals. But if you have an arrow inside the diamond, you are dealing with a current source. So I need you to get that one straight. A positive and negative is telling you arrow inside it is telling you that it is a current source. Then I now tell you that there are four major types of sources when we are talking of dependent or control sources. Remember that dependent source or control source means that they are whatever quantity of voltage or current in them is determined by another source. They don't have their own source. That's why we call them dependent. Just like you are depending on your parents, this particular facility as well is depending on the source that may be able to help it. Please use your matric number. I have said this over and over again with your name. let your matric number. Can the class rep please help me with this? We shouldn't be going forth and back, and nobody's mic should be on when you are joining. There's a way you can do your mic that will not make noise when you are just joining. This interference is not the best for us. So as I was saying, voltage control voltage source has to do with you have the voltage control, that is the one that is depending on the voltage source, is a voltage that is positive diamond. Then you have your bubble, others on the other side. Then the two of them have both voltage source and voltage control. When you have a bubble with positive and negative terminal, and you still have diamond with arrow inside, then you are dealing with current controlled voltage source. Bubble the one that is being controlled, and you have current source, voltage control voltage source. And on the other side, you have bubble with arrows. Thank you. I think I need to move on because we still have a long, long way to go today. So this is what we did last week. So whenever you have voltage control voltage source, this is how you will have it. So you will have the diamond with positive and negative bearing, and then with that diamond, you have voltage control voltage source. In the second one, you have the positive and the negative. Then inside the diamond symbol, this one we call it voltage control current control voltage source. Please, I'm in a lecture. I'm in a lecture. I'm in a lecture. I'm in a lecture. Please. So, in other words, you have that as that, and then when you have arrow inside that diamond box, you have vote and you have positive.
Well, that's why I don't go.
You guys should mute your mic. Mute your mics.
ọmọ ẹni rẹ̀ sì ti dé obìnrin ń ta sánsán.
May una go add lecture back, abeg.
Tíṣà jọ̀wọ́, ẹ wá lọ́wọ́
Nobody
kan.
comment am now. Na in network.
Tíṣà
Omo
jọ̀wọ́.
nothing like nothing like that too. No be network o.
Let me see one come video.
Ọmọ inú rẹ̀ sì ti dé.
Lecturer don Japan.
Omo, ṣá na wahala o.
Àlàkẹ́ Àṣàkẹ́.
Maybe everybody comot now. Make the man those back now.
Abi?
Tíṣà jọ̀wọ́, 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 ẹ wá
Who go lead us
You
like
go
this?
just see them. You go just where Moses dey? Moses no dey here, sha o.
Why they find me?
Na Moses dey lead the daylight now. You understand
See
now?
what? See what?
Ẹ̀ta sọ́sọ́. Àlàkẹ́ Àṣàkẹ́.
Make one person comot na me lecturer enter class now.
Okay.
No, I expect you people to behave yourself. If you don't behave yourself, what I will do with this lecture is I will do a recorded lecture, and we go and watch it on your own. I think I need to meet with all your class rep physically by tomorrow. No, by Wednesday. Wednesday, all the class rep must make themselves available in my office by 12 noon. Because this is becoming too much. I've been taking this lecture for years now, and this is my 4th or 5th year of taking it online. This is a course I've been teaching for more than 15 years. So all this disturbance is not allowed. I gave instruction that you should put your matric number and your names. With your name first. A number of you are still misbehaving. I may stop direct lecture whereby you can ask questions. Go straight, record like that. Once you come late, I expect you to go straight to the YouTube and join the YouTube channel. I shouldn't go up and down. There's a lecture going on, and some of you are just popping in at almost and the 12 noon. My students have become PhD holders. Some of them are professors, both in Nigeria and outside Nigeria. How can you be behaving like this? Don't let this speak self again, because distracting my lecture is totally on.
Yeah, sorry, sir.
Yeah, sorry, sir.
Saying before the network. Thank you. As I was saying before, the network caught circuit is a word from cycle. CIR LE to derive from circle. So a circle has beginning and it has an end, and the beginning and the end, they meet. That's why you call it a circle. Likewise, a circuit as well must always close. Any electrical configuration that is not closed is not a circuit. It is only electrical parameter put together that are close that you can be talking of a circle. So on the circuit rather. On that note, there are several components that make up a circuit. You have what the branch. I to be writing because I'm still going to follow this branch as part of the elements the circuit. You have node as part of the element of the circuit, and you have a number of other things like loop or mesh as part of the circuit. So I want to pick them one after the other. Now, when you are talking of a branch of a circuit, what we are talking about is that there are two terminals that are connected with one or more elements, circuit elements now. I've told you the circuit elements are resistance, inductance, or capacitance. So these are your circuit elements. And likewise, you may have the sources, which can be
Sir, we
current
can't see your
or the
screen.
voltage.
Sir, we can't see your screen.
You can see the screen. Maybe it is
Yes, sir. Yes, sir. We can't see it.
Been seeing it for a while.
okay. Let me try it again.
Yes, sir.
Can you see it now?
Yes, sir.
Yes, sir. Thank you, sir.
Yes, sir. Yes, sir.
Yes, sir.
I think come up now.
Yes, sir.
Eh?
No, sir. It has stopped.
No, sir.
It came up
Why
earlier,
did it
but it
not
has
move now?
stopped now.
Okay. What of now?
Yes,
You have
yes.
Yes, sir.
Yes, sir.
Yes, sir. Thank you, sir.
okay, okay. So let me repeat it all over again then. I said that when we are talking of a circuit, the word is circuit is from cycle. And you know that when you are talking of cycle, cycle has a beginning and it has an end. And they call it a meet. That's why you can call anything a circle. The same way with circuit. Circuit starts from a particular point and it must close for you to call it a circuit. If it does not close, it is no longer a circuit. So when you are looking at that circuit, there are several parameters or several components. That branch, you have what we call the node, and then you have what we call mesh. And how this work together, this branch mesh, they must. And last week I told you about circuit elements. I told you that beyond them we have the inputs. What determines if a particle is a node? So I want to pick up each of these branch, node, and loop. Each of them, I'm going to define them and give you information about them. When you are talking of a branch, all that you can see on your screen now in electrical circuit, we call them branches of electrical circuit. Is any portion of a circuit with two terminals connected, and on that occasion, I want you to take note of that. There must be a circuit element or more in a particular branch. Look at the first branch that we have by your left hand side when you are looking at the screen. You find out that I call this a branch voltage, and the current flowing the other way around with the purple pink arrow, I call it the branch current. So a branch has a circuit element, at least, for you to call it a branch. So terminal A, terminal B makes up, when we are going to call it, we will say AB is a branch. That's a branch. Likewise, where you have resistor, that ideal resistor, where you have that resistor is another branch. Remember the formula, the definition of a branch is that it may contain two or more circuit elements. The first one has source or battery, what we call battery. Look at the third diagram as well. You have almost the same case here. There is a battery and there is no other element there. It's still a branch the way it is. A practical ammeter, where you have ammeter and it is internal resistance as connected, is also a. Now I want to move on to node. I told you that I'm going to be dealing with three things: basic circuit concept. The first one is the branch, the second one is the node, and the third one is the mesh, or what you can call loop. Now, when we are looking at the node, for a node in electrical circuit, it has several branches connected together, soldered together. I will rather use that word, soldered together, by soldering iron or whatever way you want to put together. So you have two branches, all those branches that you solder together to one point is called, that point that solder them together is called a node. It's called a node. So on the account of that, on the account of this new development, then you have uh, a node is the junction of two or more branches, and then one often junction of only two branches as a trivial node. In effect, any connection that can be accomplished by various terminals together is a node. And look at it closely. Underneath, on your left-hand side, you can see the node where you have four branches coming together. Four branches coming together.
How did you get to?
So four branches coming together. And look at the second one. You have node A and node B. Because there are different terminals. You call one node A. You call the other one tutorial that I have already given to you. You need all this for it. You have you're going to three branches. You join them together at that point. But you need to and
Sure. Let's try the movie again. We are having network issues. Where's lecturer?
sorry, it was network challenge. I have changed to another network now. I want to believe it will work fine. Can you hear me?
Yes, sir. Yes, sir. Yes, sir. Yes, sir. You can see it, sir.
Okay.
Yes, sir.
Yeah. Can you see the slide?
Yes, sir.
Yes, sir.
Yes, sir.
So just like as I was saying before, so you can see the various types of nodes that we have. And then if you look to your right hand, the diagram on your rightmost hand, you will discover that you have a place that I label as supernode. You may want to ask me, what is a supernode? A supernode is when you have a source, the way you have a source there, and you have resistor joining it. Instead of just representing it as a node, you can bring all those parameters inside that dark region together as a node. So a supernode is obtained by defining a region that encloses more than one node. So you can see three nodes are put together in this place to form a supernode. And I said here that in practice, any circuit element with two terminals connected to its branch can form a node, as I've told you. But supernode can be treated in exactly the same way as you treat your nodes. I want to show you a more elaborate one. So a supernode is a combined node that is created when two or more nodes are connected by a voltage source. So it is treated as one big node for circuit analysis. You can see when you have a supernode, look at that blue dotted lines can form the oval shape around the two nodes. So V1 and V2 are being brought together now, though they are two different nodes, but they are being brought together to form a supernode because of the presence of that voltage source between them. Likewise, you can see it again. It is often a representation of the voltage source that determines when you will have this kind of elements. That is the supernode. So you can see for second diagram, even in this particular circuit diagram, you have two supernodes. You have one that is ideal, which is the one that is independent. The 20 volts is an independent voltage source, while the 3Vx is the dependent voltage source, which is otherwise known as controlled source. So you can see you have two supernodes here. All these problems, you should be able to solve them and be able to get answer to them. All you need to do is that when you put together all these nodes as one point, you try to use it to resolve this problem. And by the time you finish resolving the problem, you come back and you get the value of the Vx. You know, Vx is a value there that you need to get, just like you need to get the voltage V3 and V4. And likewise, if you look at the third one, you will see that there are, I call it multiple supernodes. Why? Because you have two of them, but the two nodes are defined by the voltage source. The independent voltage sources are the sources of the voltages there. And then all sources of voltage there. And then you have the 10 volts and you have the 15 volts. So you can use this to resolve your circuit. The supernode helps you to solve circuit much easier. And then you can now come back, and after you have obtained the values, you can then come inside those supernodes to come and resolve the parameters or the circuit elements that are there that are unknown. These are some of the importance and the benefits of using supernode. We have what we call loop as well, which is another name for mesh. I've been talking of mesh. Another name for mesh is loop. A loop or a mesh is as defined. Any branch that is enclosed is a loop. Any enclosed branch is a loop or is a mesh. So where you have the branch resistor, one resistor branch, another resistor branch, and another resistor being shared by loop 1 and loop 2, and then you have the reference line. By the time you go around that circle and there is no opening, you call it a loop or a mesh. And when you are going to work with it, you can see the way it is represented. You have loop 1, loop 2, and the loop 3 goes around the whole. So in this case, you have 3 loops here. In the case of the second diagram, where you have Vs and R, you have only 1 loop. But in the case of the next one, you have more than 1 loop rather. And then we have 3 loops, just like we had in first diagram. Because when you take inside of the first one, you take inside of the second one, that's loop 1 and loop 2, then the entire circuit will form your loop 3. That's why I ask here, how many loops do you think we have? And I put it as 3 loops. And the nodes, you can see the nodes before I move on, because we are going to be encountering such things. For the last or the third circuit, with 3 loop circuit, capsule with 3 loop circuit caption, if you look at the arrow from the current source, you will see that there is no resistor, no capacitance, no circuit element between that point and until you get to where there is a junction node with 3 branches linked together. Now, when you don't have a circuit element along a particular branch, then that branch is not a branch. When there is no element, electrical element, either the electrical circuit element, if I may call it like that, once you don't have it along a branch, that branch is not known to us in analysis of circuit. Please take note of that. In other words, the line that is joining the point from the IS to the node where you have 3 branches joining, there is nothing between that branch, that point of the node, and the IS. So there is no branch in that place. And so the node becomes 1 instead of counting the nodes as 2. And if you look under, the bar that joined from the end of the ammeter or IS to the last circuit branch, you will see that there is no circuit element there. The same thing is applicable here, in the sense that all of them, they form just 1 node, because there is no circuit element there. So it is 1 node. All those 3 nodes that you see, they can be joined together to form 1 node or 1 junction. All of them can become 1 junction because there is no circuit element there. Now, when we are talking of mesh, I have spoken about this, the first circuit. Let's look at the second circuit. If you look at the second circuit, you will discover that the meshes are simpler to visualize in a complex network than loop. So you have the mesh 1, mesh 2, mesh 3, and you have mesh 4. There is an occurrence there that I want you to take note of, because I'm going to somewhere where you have that current source. The current source has a very important role to play because it's between 2 meshes, mesh 2 and mesh 4. Please look at it closely because I want to move to the next slide so that I can use it to explain better. That current source that is between mesh 2 and mesh 4, it has a role to play in that place. So that role is called the super mesh. That role is called the super mesh. What is a super mesh? Just like you have super node, you also have super mesh. A super mesh occurs in a circuit when 2 meshes share a current source between them. Please let me step backward by 1 slide. You can see the current source between the mesh 2 and mesh 4. So because we have that mesh 2 and mesh 4 with a current source in between them, then you are dealing with a super mesh between current mesh 2 and mesh 4. So that is what we try to enumerate or elaborate upon in this next slide. The first circuit here, you will see that you have a bridge, Wheaton bridge arrangement, but you have a current source across the bridge. If you look at it closely, you have a current source across the bridge. So we can form a super mesh just with that blue triangular boundaries. So that's why it is labeled super mesh. And likewise, if you look at your right-hand side, you see another circuit there where you have another current source, 3 amps, and you have the voltage source that is independent voltage source, and then dependent current source on the other side. So on the account of that, you can have a super mesh. The super mesh here is the one with the dotted lines carrying arrows. That's the super mesh. In other words, you will do as if that branch containing 3 amps is not in existence. So you will do as if it is not in existence, and then you will work out your problem without it. So this is still going further with super mesh. This is a typical problem with the current in between, current source in between. But look at it, you can solve the problem. Meanwhile, look at the general way that you can solve it. If I say find mesh 1, mesh current 1 and 2, or current flow in mesh 1 and 2, you can work it this way by using your KVL. And your KVL will be able to give you what we have here. But for both mesh 1 and mesh 2. And at the end of the day, you can equate the answer for mesh 1 and mesh 2 to give you what we have in the middle. And at the end of the day, you can go ahead and get your answer by looking at it and say, I1 minus I2 equals to 1A. But to make it faster, you can use a super mesh technique. In the case of super mesh technique, all you just need to do is to disconnect that current source, which is done here. And when you do that, you can now go ahead, do your evaluation. By the time you are done with your evaluation, you can now calculate for I1 and I2, and it will still give you your answer. If you work this problem, you get 3 amps and 2 amps respectively. 3 amps and 2 amps respectively. And by the time you say 3 amps minus 2, it will give you 1 amps. That means the formula is correct that we have used. So these are some of the ways that super mesh can be used. Instead of going through a rigorous and longer route to get your I1 and I2, you can get it by just using the super mesh approach. So that's the essence of some of these things. Now, having given you these 3 major parameters, the node, the branch, and the mesh, or the loop, we can now move to what we call network analysis. When we are talking of network analysis, it means we want to determine each of the unknown branch current and nodal voltage or node voltage in each of our branch. If you have a branch or several branches making up your circuit, what network analysis does is to give you the branch current, to give you current through each of the branches, and the node voltage, that is the voltage at each node that make up your circuit. So it is therefore important to define all the relevant variables very clearly when you are working these kind of problems. You must define everything clearly. As you know, that current is the time rate of change of charge. That's the way you were taught. Time rate of change of charge. So you already know that. And so on the account of this, you'll be able to get your answer and be able to determine the unknown variables from the known variables. Now, there are several laws that are very much used in the network analysis. But I'm just going to give you the basic ones. I'll give you the voltage, what we call Kirchhoff's current and voltage laws. These laws are they are like our tool in electrical engineering. Once you know your KCL very well, your KVL very well, which are the offshoot of your Ohm's law, then you are sorry for the loss of network once more. I wouldn't know why this network is going off and up. I've changed to 3 different types of source of supply, but it's still the same challenge that we have been having. That is totally regretted. So, as I was saying, both Kirchhoff current and voltage laws, they are very crucial to our study when you are dealing with electrical systems. So what does it mean? What does voltage, sorry, it's as if I was on, okay. What does this law mean? In other words, the current flowing from a battery to the light bulb that I saw below is equal to the current flowing from the light bulb to the battery. Look at the circuit that I placed below. There is a battery there, 1.5
So can I see your screen?
volt battery. You have here 1.5 volt battery, and that 1.5 volt battery is supplying a light bulb. And I am telling you that the current that is flowing from the...
Can see your screen.
You can't see my screen. Okay, let me try it again.
I can
So we can see your screen.
Yes, I do.
see.
So that's its own network.
No, it's paused for some of us, sir. Your screen is.
Yeah? Hello?
I can see it just fine now.
Is your
Me, I
network
also
already
can't
Ah,
see
I
it.
can't
loading?
see it.
It may be your network.
No, you pause the screen. Okay, yeah, I can see it now.
Yeah.
Okay, I can see it now.
Okay. So, as I was saying before now, that if you look at that circuit, you will see that the battery, 1.5 volt, is supplying the light bulb. And looking at it, the current is flowing from the battery and it's flowing to the light bulb, and it's flowing from the light bulb back to the battery. That's what we call a circuit in electrical engineering. So it completes this cycle. So the same way that everything you are doing must always form a complete cycle. That, remember, I told you a cycle is where you begin, you end up there. The same way, this current that is flowing out of the battery returns back to that battery. That forms a circuit. So on the account of that, I said that If the current is flowing the way we have shown it, it then means that no current is lost going around the closed circuit. So the current that started the journey is the current that came back to the source. So this principle was observed by a German scientist called Kirchhoff, and is now known as Kirchhoff current law, KCL. What does Kirchhoff do? Kirchhoff's current law states that because charge or current cannot be created but must be conserved, the sum of the current at a node must equal 0. I think you can relate with this. You cannot create current, but you can conserve it. And on that account, when you take a node, the total current in that node, we call it algebraic sum. Algebraic sum, as we have put algebraic there. Algebraic sum of the currents at a node must be equal to 0. And that is what you have here. Look at this other diagram now. That battery that was supplying only one light bulb is now supplying 3 in parallel. Look at it closely. Since we have said that current cannot be created but can be conserved, or charges cannot be created but can be conserved, then we have the algebraic sum this time around, that at a node, what is going out must be equal to what is coming in. Because for you to get 0, it means that when you add everything together, you will get 0. But for you to get 0, some must be positive, some must be negative. So the one that is coming in into the node, you can represent it as a negative, while the one that is flowing out, you can call it positive. And if you look at the diagram I showed to you on this slide, you see that I1, I2, I3, they are going out to feed the lamp. Then I call them positive. And the current that is entering that node 1, I call it negative. So illustrating the Kirchhoff law at this node 1 now, you can see the mathematical expression that I have there. Minus I plus I1 plus I2 plus I3 equals to 0. I said that the significance of Kirchhoff's current law is illustrated by the diagram on the left-hand side. So you have seen it here. And in the above KCL equation, current entering a node is being defined as negative, while current exiting the node is being referred to as positive. That's exactly what I have explained to you. Please take note of this and take note of that statement that I've made. Because current going into a node, you must treat it as negative. And current coming out must be treated as positive when you are doing your circuit analysis. Now, the second aspect of it is of this network analysis. I've told you that Kirchhoff developed 2 laws. We have looked at the current law, and the current law tells us that the total current entering into a node must be equal to 0. And this can only be possible if the current coming in is taken as negative and the current going out of that node is taken as positive. So when you add negative and positive, they will cancel each other out. And so you will have 0 at the end of it. I think this is well explained. Now, when we go again to another stage, current and voltage, they are always relating. In every electrical circuit, we have current, we must have voltage, current, voltage, current, voltage, current, voltage. If Kirchhoff has been able to give us current law, then there should be voltage law. So Kirchhoff also developed what we call Kirchhoff voltage law. And when you are talking of this, I want you to look at the circuit below. And you can see, first of all, look at the one by your left-hand side. You have the battery, 1.5 volts, still the battery. And the voltage drop across that battery is V1. And there are two terminals, A and B. The voltage drop across them is V2. So we are now saying that by the principle of law of conservation of energy, that no energy is lost or created. Remember, when you were taught law of conservation of energy in your secondary school, you were told energy can neither be created nor destroyed. So you cannot destroy energy and you cannot create energy and you cannot lose energy. So on the account of that, the sum of all the voltages associated with the source must be equal to the algebraic sum of the load voltages. So if I have 5 loads tapping, receiving power supply or energy from the same source, then all of them, the voltages across each of these loads, by the time I add them together algebraically, they must be equal to the source voltage. I think you are getting it. They must be equal to the source voltage. So the algebraic sum of the load voltages must always be equal to the source voltage, so that the net voltage around this closed loop circuit is also 0. When we were talking of current, Kirchhoff current law, we said that algebraic sum of current entering and leaving the node is equal to 0. So the total entry must be equal to the total going out. But in the case of Kirchhoff voltage law now, we are saying that algebraic sum of the voltage around a closed loop or a closed mesh or a closed circuit is always 0. That is, by the time you look at the source and the load, when you balance the two voltages, they will be equal to 0. So we can say in the Kirchhoff's law that V1 is equal to V2. Because V1 minus V2 will now give you 0. So now I want to go a little further, that we need to set what we call a reference voltage. And that reference voltage is often called ground, because you can't deal with voltage without having a reference point. And this reference point, the choice of the reference point is normally called ground. But you cannot use arbitrary point for this ground. We want to illustrate this ground with a fluid motion. Let's look at a water tank or tank of water, whereby the tank is located at a certain height above the ground. So look at this tank. We want to use it to describe what a ground should be in electrical circuit. The water is flowing out at a particular point, whereas the physical ground, you can see it, but the ground for that water is at H2, because that's where it is, the lowest point of that water is. The rest is just the support. So the same way with a circuit, the ground for the circuit, you have to find a practical use in the ground voltage of a circuit. So we normally represent the ground, as you have seen in that circuit, and then it can be a value that has been agreed upon. The circuit symbol for the earth ground is a zone, while the circuit symbol for chassis ground is a zone. So when you are dealing with circuit symbol, you will see that it is 3 horizontal and parallel lines with decreasing sizes, or length as you go through from the top downward. But when you are trying to ground or a chassis is like your vehicle. That's a chassis. You can connect, and we normally connect a wire to the chassis. So you are grounding the chassis by doing that. So when electric circuit flow through a metal wire or through other circuit element, it encounters certain amount of resistance. I'm going to IV characteristics now. Do we have question based on what we have discussed under Kirchhoff's law before I go to IV characteristics? If there are questions, let me see your hand. Okay, you can't ask questions because you didn't write a full detail of yourself. Any other person who wants to ask questions? It's only those with full detail that I can ask questions. Yes, any question for, okay. Akindeng, can you ask your question before I go to IV characteristics? Akindeng. If you can't ask it, let me check. You can, if you cannot be able to ask, you can write it on
Okay.
the chat box so that I can go through it.
So you were saying something about the last slide now. You were saying something about 3 horizontal and 3 vertical lines. I could not really point it out in the diagram.
Okay, just a minute. This, where is it now? Let me, okay, this one. This, if you look at the diagram here, you will see the circle symbol for earth ground. Can you see it? Circle
Yes,
symbol
sir.
for earth ground. So you can see that there is a bubble, a line, vertical line, and then you have 3 horizontal lines under the vertical line. Those lines, we normally make it 3, and they are of decreasing sizes or length as you go from the highest to the lowest part of the drawing. Do you get it now?
Yes, sir, I did. Thank you.
So that's how we normally represent ground in the electric circuit. And if you look at the other one that looks like a shovel, we use that circuit symbol for chassis. And I use your vehicle or your dash vehicle as an example. The iron part of that vehicle is called chassis. So we normally connect their own ground to that chassis. And if you work in industry as well, the body of some of the machines are used as the chassis. And the same thing with generator. A number of times, their ground is connected to the chassis and the chassis to the ground. So you have this kind of thing in a number of times. Okay, so if there's no other question, let's go to IV characteristics. What do I mean by IV characteristics? I stands for current, V stands for voltage. In some textbooks, you may see it as VI, that's voltage current characteristics. Wherever you see characteristics, it's telling you that there is a relationship. So some other book, we call it IV relationship, that is the relationship between current and voltage. And to tell you the truth, from Ohm's law, the relationship between current and voltage is nothing but a relationship that we can call the Ohm's law relationship. And that what relates them is nothing but the resistance. That is the constant when you are relating V to I. So we are going to be using resistance a lot and some other circuit parameters, elements, a lot in this wise. Resistance to the flow of current may be undesired. For instance, in the case of a lead wire and connection cable, but then it may be exploited in an electric circuit in a useful way. But in this place, we want to start by looking at ideal resistor. Ideal resistor exhibit linear resistance according to Ohm's law. What we are saying in essence is that the relationship between V and I may not generally be a straight line. But by Ohm's law mandate or concept, the issue of straight line or linearity is often acceptable. So look at this. This is IV characteristic for a particular electrical facility or electrical circuit. The resistor is as drawn in this place with that is in that pink color. That's the resistance. You have the cross-sectional area labeled as capital A. You have the length of the resistor as L. Then you remember your formula that we normally use. That is R equals to L over rho A. So that's the formula that was able to generate that. However, in IV characteristics, you have the resistor as connected as a branch of an electric circuit as you have seen it here. That's the circuit symbol of that resistance. You can see the physical symbol, you can see the circuit symbol. Then for us to get the IV characteristic for this particular resistor, we use this formula of the Ohm's law. When current is zero, voltage will be zero. When current is increased, voltage will increase. And that is why you have that particular IV characteristic passing through the origin. I want to believe you get this. We have assumed that we are following the Ohm's law concept, that we are dealing with an ideal resistance, whereby the relationship between V and I will be a linear relationship. And so that linear relationship will pass through the origin as we have shown it. So for resistance, the IV relationship normally passes through the origin, and it is a straight line and linear in nature. Now, voltage as well, you can determine the IV characteristics of a voltage source as we have it in this place. The voltage source, you have the bubble as indicated if you are dealing with the system either as a battery or as a bubble. And at the end of the day, the current is flowing out through the positive and entering back through the negative. But then, when you want to construct the IV characteristics, look at it. Your I is on the horizontal line and the V is on the vertical line. So because the voltage cannot change value, it will have one value all through. Remember, that's what we said all along when we are looking at independent sources. And if that is the case, then the Vs will remain constant on the same spot along the V axis all through the rest of that description. While current may vary, the voltage Vs remains the same or true and remains constant. I want to believe that you get this understanding. Then beyond current, beyond voltage alone and resistor alone, we can bring voltage and current together. If you bring voltage and current together, you will get another description that will look like this. How I wish I have opportunity of showing you this on a notice on a board. What we are trying to do here is that your voltage is equals to, if you are looking at this circuit on your left-hand side, voltage Vs or the battery of voltage source is connected to a resistor. And there is an output between positive and negative, which is called V. So that output is called V, and that V will be the output, which is equals to your Ohm's law. So when you are using Ohm's law, you will go around that circuit from V equals to, as you go around the circuit from in a clockwise direction, you will come across the Vs first. And when you pick the Vs, because we are moving from negative hand of the Vs to positive side, as you go horizontal, as you go clockwise, rather, as you go clockwise, you will go from negative to positive. That means your Vs will be positive. That's why you see equals to Vs. Now, resistor, you have positive at the other side of resistor and you have negative here. So at that point, your resistor will be minus Ri, and the current that is flowing to the resistor is I. By Ohm's law said V equals to Ri. So you can easily say Ri, I, so that you will have that. So if you want to draw the IV characteristics now, look at what happened here. Your voltage Vs still has a value here. So Vs will be your highest point on that V axis that your IV characteristic will start from. But how will it go? Will it go up or go down? It will only be determined. Look at this. Here, your Ri is going through the origin. But here, what you have is minus Ri. Because it's minus Ri, you will have to flip this over by a degree. And when you are flipping it over, it is the process of flipping it over that you have it, instead of passing through the origin, it passes through like that until it gets to cut the I-axis. And the point at which he called the I-axis is called Vs over Ri. Vs over Ri. And you know V over R, it will give you current. So Vs over Ri is a value for current at that point. Do I have any question before I move on? I know this is a very serious area, so I want to take it a lot slowly. Any question, please? Okay, if there is no question, so I can move on. Yes, Akinri Ade, what's your question?
That is how did you get RI as negative? That I don't understand.
Ri as negative.
Yeah, in the equation here.
I have told you, when you move around the circuit, remember the formula for KVL, that your algebraic sum must be equals to 0. And your source is Vs. So any value you will get will not be greater than Vs. Do you understand
Okay,
that?
sir. Yes,
So
sir.
once your source cannot be greater than Vs, then because I have told you under KVL that the algebraic sum will always be equals to 0. This is the slide that I
Zero.
used to show it to you. So on the
Yes,
account
sir.
of that, if you are going to run this circuit, you will go from Vs to this to this. So on the account of that, Vs will be the highest value. So the other two, you will add them together to equate them to Vs.
Yes, yes.
So that's how we came about that. Is it clear now?
Yes, sir.
Yes, sir.
Okay. So I want to move on to the another slide. Hopefully, maybe I should stop here because I was expecting that there'll be more questions. Well, I'm almost through. They are all IV characteristics that I will treat. Let me just finish with the IV characteristics. Now, still going on with IV characteristics. In this place, we have the VS, the RI, like before, but now you have a load. But this time around, your load is a variable load. That's why you have that arrow across your RL. When you have arrow across your RL, it means it is a variable load. So when a variable load RL is connected to a real source from the KVL, from the KVL, we can get the answer as follows. I believe from what I've explained when Arkini Ade asked me, you should be able to write that equation, RLI plus RII minus VS equals to 0. So from there, you can go on and get your VL, whereby your VL is equal to RL over RL plus RI VS. So in order to get your equation, your diagram, you need to bring in some further understanding of your VI characteristics. Your IV characteristics. Your VS will still remain the same, but your RL, which will give you your VL, and RI, we have to have a part to play. For the RI, there is no problem in the sense that you have used RI before in this place, but it is like this. RI is like this. But then, with the introduction of VRLI, RL, because it's variable, it cannot remain like it was here. Remember, it passes through the origin here, and it was a straight line. But in this place, it's passing through the origin as well. But it's no longer a straight line because of what? You have a variable load. Please take note of this because we encounter them in the laboratory when you are doing the laboratory experiments. So you can see the difference between this now and the first one I introduced to you. The first one I introduced to you is just RI. But here you have the variable load beyond the RI that you have. So the RI is giving you a pattern that is to follow, but it's not giving you the appropriate or accurate form that it should take. So the RL, because it is a variable one, is the one giving you the appropriate pattern that it should take. Likewise, when we are dealing with current source, you can get the current source IV characteristics as this. Just like you have VS, showing that the current, the voltage is the same, but the current is varying. In the case of IS as well, the current is the same at IS, but it is varying with voltage. Voltage keep on varying. So we still have the same approach here, which is like the one I shared with you earlier on. So we are just replicating what we did for voltage source in the case of current source. So the third one, which is another parameter, is the capacitance. When you have capacitance in a network or in a circuit, and you want to test the IV characteristics, this one, you won't see this one in the laboratory. I just brought out this one in order to just show to you that all the electrical circuit elements or device can be, the VI characteristics or IV characteristics can be determined. That's what I'm just using this to do. So don't worry, it will not be part of your laboratory experiments, but you still need to know about it. In which case, you have the two plates. When the two plates are equal, you are talking of capacitance. And the two plates are conducting, one will be conducting in the positive direction, while the other one is in the negative plate. We call one positive plate secondary negative plate of the capacitor. And you can get the current equation as you have it here. So looking at this, you can see this as well, IV characteristics. This is the best way to demonstrate it for what we can see in the laboratory. The conducting plate with the cross-sectional area as shown. And between, let me quickly say this, for every capacitor, there is always an insulator in between. That insulator can be air. You know, air is an insulator. That insulator can be paper. That insulator can be mica, as many and many other things that are called insulators. What is insulator? Insulator is any material that is not conducting electricity in any way and in any form. Any material that is not conducting electricity is called insulator. Another name for insulator in electrical engineering, we don't just call it insulator, we call it dielectric. Dielectric is another name we call it. When we say something is a dielectric, it means that it's an insulator. So on the account of that, we normally have what we call dielectric constant or dielectric strength of the insulating material. So it is very necessary for you. I must say this, that there is a level you get to that what you call the insulator can break down. The insulation can break down, but I will not teach you this. It's a teaching for those of you that will pursue electrical engineering to 400 and 500 level, where we now have what we call breakdown of dielectric material or breakdown of insulation materials. But now, your own is to believe that insulation or insulator is between the two plates, and that insulator does not break down at your own level. It doesn't break down. The current does not flow from the positive to the negative directly. So the purpose of insulator is to create a medium where there won't be interaction or flow of current from one end to the other. So we have this as the way we can demonstrate or derive the voltage for a capacitor, the current for a capacitor, and so on and so forth. And then we can determine the energy stored in a capacitor. We often call it electrostatic energy. When we are talking of energy stored in a capacitor, we call it electrostatic energy. And so we have the diagram and the demonstration that you have there. And then you have the equations as written, which I know that many of you have done it in your secondary school. Some of you did it during the time you were going through physics courses here on campus. And so we have that information for you here, just to refresh your memory. So lastly, for today, and resistor has color band, and then the color band at times are given different 4 color band on a resistor bar or body. The B1 has its own value, the B2 has its own value, the B3 has its own value, and the B4. Let's take, for instance, the band 1. Let's assume it is brown. Then when you say it is brown, you will go to the code. Where do you have brown here? You will pick the brown, the value of the brown. Then the band 2. Let's assume it is also brown. You have the value there. Then the band 3. Band 3, in this case, you must multiply by a value, while your band 4 is your tolerance, which is in percentage. So this color code, even though it is not captured in color, I want you to look into it, because when we get to the laboratory, you are going to be identifying some of these resistors, and I will ask you to tell me what is the color, what does the color code stand for, and you will have to give me the value of a resistor. By seeing those color code on a resistor, it should be able to tell you what is the value. It can tell you that the value is 4.7 kilo ohms. It can tell you that the value is 2.8 kilo ohms, or 4 ohms, or 10 ohms, depending on the color band that you have. So I will give this to you to go and read about it, because it's not something we can discuss over the internet like this, so that when we meet in class or in the laboratory, we can look at this together. So this brings us to the end of today's lecture. Any question at this stage? If you have any question, let me know. We still have about 10 minutes to go. Let me see if anybody has a question or any question. Okay, if there's no question, can you put down your attendance as usual with your matric number, your surname
Yeah,
first,
can you send the
another
slide?
name. Oriyomi, you don't belong to this class, because you cannot be using your name without matric number. Bye for now.
Sir, can we drop it again, sir?
You did not. I told you people to always use your matric number with your name. I don't know why you are not ready to do that. Use your matric number with your name. That's what I normally tell you guys. Your matric number should go with your name. So I think with this, we are through with the lecture today. So
Excuse me, sir. Will you drop the
the
slides?
class rep should see me on Wednesday on Felony by 12 noon. All of you together, the 10 of you. I think you should be 11 now with physics. The 11 of you should see me by Wednesday, 12 noon, for an important meeting, probably at the HOD's office. Come to the HOD's office, because my office may not be able to contain all of you here. So please, by now, the laboratory people are getting ready for you. We'll be introducing you to the lab once you are residents within the campus. I mean, once the hostel is open for you to come in. But for now, we can't start any laboratory until that is settled. So, but I have told your class rep to go and see the head of the lab unit, and I'm going to the lab now to go and evaluate the kind of information that you have been given. We are ready for you. We have prepared the laboratory, made it ready for you. But I have told the class reps, I saw 2 or 3 of them, I said they should go and make a further discussion with the head of the lab so that we can know, we can have sufficient information that can be passed to us on our platforms. Class rep, any information you get from me or from the people assisting in the lab, as well as from other lecturers that we are on this call together, you must pass it on the board, on your class group chat. Don't keep any information to yourself. Now, the submission of your first assignment is next week. Don't forget that. By now, you should have concluded it, gotten it ready for submission. I know that a class rep came to me that the textbooks, those textbooks are online, you can download. But I have told those who cannot get it, you can come with a flash drive so that I can forward it to your, I can pass it across to you and you can share with within yourselves. I have tried to send it by email and WhatsApp. It has not been that easy. It has not been that possible. So on the account of this, your class rep has some work to do in this regard. Thank you.
Sir, which assignment is that?
Is this in the call?
Please, so is there an assignment that the man gave us?
For your own
Please,
experience now.
is there an assignment that the man gave to us? Please, anybody.
Check the GET201 first day package.
GC what, please?
GET201 first day package.
GC21 what? Sorry, please.
GET201 first day package.
Okay. Thank you.
Yeah, there should be. I think you gave us an assignment there.
Okay, thank you.
You're welcome.
What did you say?
I said you should check the GET201 first day package for the reading assignments.
Deixa eu dizer, então, what's your one single?